Hello Year 10. Today we're going to be solving quadratic equations by factorising, but before we do that we're going to do a quick review of the completing the square method that we learned last lesson. So the first question, we are factorising x squared minus 12x plus 10. So what we do is we take the first two terms, x squared minus 12x. We take the 12 that's in front of that x, we halve it, so half of minus 12, and square it. Half of minus 12 is minus 6. Minus 6 squared is 36, and I'm going to add 36. And because I don't want to change the size of this expression, I have to minus the 36 back off again and add the 10 from the original question on the end. The first three terms that I have created here are going to make a perfect square. To factorise it, you halve the minus 12, which is minus 6, and it'll be x minus 6 in brackets squared. The minus 36 plus 10 makes a negative 26 that goes on the end. Now what we have here is a difference of two squares. So to factorise it completely, we need two large sets of brackets. We square root the x minus 6 squared, which will be x minus 6 at the start of each bracket. And then we square root the 26 at the end of each bracket and have 1 plus and 1 minus sign in between. Okay, for a slightly harder example, we have question 2, which we're factorising 4x squared minus 8x minus 16. This question is harder because of that 4. We don't like to use the completing the square method while there is a 4 in front of our x squared. So what we do is we factorise the 4 out. And that gives x squared minus 2x minus 4. Okay, then we are going to complete the square. So leaving the 4 out the front, we take the first two terms, which will be x squared minus 2x. Then we halve and square the minus 2. So half of minus 2 is minus 1. Minus 1 squared is a plus 1. I promptly subtract the 1 back off, and I have the minus 4 on the end as well. So the first three terms in here are the perfect square. They factorise to be x halve the minus 2, so x minus 1 in brackets squared. Minus 1 minus 4 is minus 5 and close bracket. Okay, then we want to do a difference of two squares with what's inside there. So we're going to leave our 4 still at the front here, and we're going to have two double brackets. And we square root the x minus 1 squared. So x minus 1, x minus 1. Square root the 5 at the end of each bracket. Oops, sorry, I put a 5 there. And then we need 1 plus sign and 1 minus sign. Okay, moving on from last lesson's work to the solving quadratic equations. Now this is going back to normal factorising again. It says here, so far we have factorised quadratic expressions. Now we want to solve the quadratic equations. This is the general form of a quadratic expression, and it would be in the form ax squared plus bx plus c, where the a, b and c would be numbers. This is the general form of a quadratic equation. The only difference is to make an equation, we are making it equal to 0. So in order to solve these equations, we're going to factorise using the different techniques that we have learnt, and then we're going to use what is called null factor law to solve the quadratic equation. Now, null factor law says that if you have two things factorised, and in a quadratic, you would have two things, two brackets, that would be times together. Now, if your equation says that those two things multiplied, and in here they've called them a and b. So if a and b are multiplied together and it equals 0, The only way for two things to multiply together and give 0 is if one of those things equals 0. So either the A equals 0 or the B equals 0. And we'll be using that fact to finish off and solve the equations. So there is a little list here that we're going to be working through. Let's read through it. Step number 1, make sure that the right-hand side of the equation is 0. So you may have to move everything across to one side. Step 2, take out any common factors. Step 3, factorise the left-hand side if we can. Step 4, use null factor. And step 5, we will solve any linear equations. Okay, here are our questions, and we can see in here that we're going through the different types of factorising that we have learned. We've got difference of two squares, common factor, cross method, and so on. So let's look at question 1. Solve the following quadratic equations using difference of perfect squares. So, or difference of two squares. X squared minus 4 is the question. To factorise it, we square root the x squared will be x and x. Square root of 4 is 2 and 2. 1 will be a plus and 1 will be a minus. And we have the equals 0 on the end because it's an equation. Now, if you've done this before, you possibly know a shortcut to use null factor from here, but I'm going to assume that for many of you this is the first time doing this, so I'm going to show the full working out for the first few questions. So null factor says that these two things here that are multiplied together, one of them has to be equal to 0 in order to get the 0 on the other side of the equation. So what we do is we take the first bracket, which is x plus 2, and we say that could be equal to 0. Or we take the second bracket, it could be the one that is equal to 0. Now, if I solve each of those little equations, from the first one, move the 2 across, I would get x equals minus 2. If I move the minus 2, move it across the other side, I would get x equals plus 2 from the second one. So there are two solutions to most of the quadratics that we do, and in this case my solutions are minus 2 and positive 2. Let's try that again. Part B. So we're still doing a difference of two squares here. So to factorise it, we're going to square root the x squared to be x and x at the beginning of each bracket, and then we're going to square root the 15, square root the 15 for the second term in each bracket. One will be a plus, one will be a minus, and it's equal to 0 because it's an equation. Okay, then using our null factor, we say either the first bracket, which is this, could be equal to 0, or the second bracket could be equal to 0. Solving each of those little equations, the first one I move the root 15 across the other side and it would become negative square root of 15. Moving in the second equation, moving the negative root 15 across the other side, it will become a positive root 15. And so there are my two solutions. So now you may be seeing the shortcut. Whatever, if it's in this x plus 2, x minus 2, the solution just becomes the opposite sign. So it's x equals minus 2 and x equals plus 2. So let's try the shortcut for this next one here. This time we're going to take out a common factor for our factorising technique. So x is the common factor, and that will leave x, take away 7 inside the brackets, equal to 0. So null factor says either the x equals 0 or the x minus 7 equals 0. So x equals 0 is the first solution, or x minus 7, if you move the 7 across the other side, it would be x is equal to a positive 7 for the second solution. Let's try that again. In question B, I can take out x as a common factor, and that would leave 3x plus 5 equals 0. So again, using null factor, I get x equals 0 from the x at the front of the bracket. Now this bracket is a little bit harder than the other ones that I've done because I have a number in front of the x. So the solution to this is not minus 5. We have to take the 3x plus 5 and make it equal to 0. Moving the 5 across, we get 3x equals negative 5. And then dividing by 3, it would be x equals minus 5 over 3. So just be a little bit careful with those ones that have two numbers inside the bracket. Question 3. We are solving the quadratic equations using the simple cross method. Okay, so these ones are going to factorize into two double brackets equal to 0, x at the front of each bracket. And we're looking for two numbers that times to give the 3, and they're going to add to give the 4. So numbers that times to give 3 would be 1 and 3, and they also add to give 4, so there is my factorized equation. Now using my null factor, from the first bracket, I get x equals minus 3. From the second bracket, I get x equals minus 1. So I've just said x equals minus 3 or minus 1, just shortening the working out right down there. Part B, same method, so we have two brackets, equals 0. X is our prenumeral. We have to times to give the 3 and add to give the minus 4. So this time it would be negative 3 and negative 1. Using null factor, from the first bracket we get a positive 3. From the second bracket we get a positive 1. So 3, 1 or 3, 3 or 1, whichever way you want to say it, is the solution. Question C, factorising. X is our prenumeral. What times is to give minus 20 and adds to give a negative 1? The answer is minus 5 and a plus 4. So using null factor, we get x equals 5, or from the second bracket, negative 4. Part D, x is the prenumeral. We're going, what times is to give negative 15 and adds to give negative 2? It's negative 5 plus 3. Using null factor, from the first bracket we get x equals 5. From the second bracket we get x equals minus 3. In question E, we have a 6 over here on the right hand side. So before we can factorise it, move it over to the left. So it's going to be x squared minus 5x minus 6 equals 0. So everything's over on the left. Now we can factorise. And we're looking for numbers that times to give minus 6 and add to give minus 5. So that would be negative 6 plus 1. Using null factor, we get x equals 6 from the first bracket and x equals minus 1 from the second bracket. Question F, it's already well, it looks like it's factorised, but not properly because of the 10 over there. So I actually have to expand it out. X times x is x squared. X times minus 3 is minus 3x. And move the 10 over to the left-hand side, so minus 10 equals 0. So that I can factorise it properly. We have x's out the front, and we say what times is to give minus 10 and adds to give minus 3? It's negative 5 and positive 2. So the solution from the first bracket is x equals 5. The solution from the second bracket is x equals negative 2. Okay, question 4. This is now in the non-monic quadratic equations. So we are going to use the factorising in pairs technique. So the first thing we do is we times the 2 with the 1, and we're looking for two numbers that multiply to give 2, and they're going to add to give the 3. So that would be 2 and 1. We're going to split the 3x in the middle to be a 2x and a 1x, or 2x and x, plus the 1 on the end. Whoop, I shouldn't have the equals there, I should have it down the end, equals 0. Now I'm going to factorise in pairs. So the first two terms, I bring out a 2 and an x to give x plus 1. The third and fourth term is already an x plus 1, but I put brackets around it so that I can see that that is my common factor. The x plus 1 will come out the front, and 2x plus 1 will go into the second bracket on its own. Next, I want to solve the equation by using null factor. So from the first bracket, I'm going to get x equals minus 1. From the second bracket, I'm going to get 2x plus 1 equals 0, which means 2x equals minus 1, and x is equal to negative 1/2. Part B, again non-monic. So to solve it, I'm going to times the 3 with the minus 2, which means I'm looking for two numbers that times give minus 6 and add to give the 5. Okay, that would be a positive 6 and a negative 1. So we're going to split this 5x to be a positive 6x and a negative 1x minus 2 on the end equals 0. Factorising in pairs, we bring the 3x out the front of the first two terms. That will leave x plus 2. Bring a minus out of the third and fourth term to get x plus 2 equals 0. The x plus 2 is the common factor, and the 3x and the minus 1 will go into another set of brackets. Okay, that's equal to 0. Now we can use null factor. From the first bracket, we get x equals minus 2. The second bracket is a little bit tricky because we have two numbers. So if we do it the long way, we get 3x minus 1 equals 0. 3x is equal to 1, which means x is equal to 1/3. You may be able to go straight to that with a bit of practice. Question C, one more of these non-monic ones. So let's times the 5 with the minus 8, which means we're looking for numbers that times to give negative 40, and they're going to add to give 18. That would be 20 and negative 2. So let's split the middle term to be 5x squared plus 20x minus 2x minus 8 equals 0. Factorise 5x out of the first two terms. That would give x plus 4. The third and fourth term, we can factorise out the minus 2 to get x plus 4 equals 0. X plus 4 is the common factor. 5x minus 2 will go into its own bracket, and we've completely factorised. Using null factor, we're going to get x equals negative 4 from the first bracket, or x equals 2/5 from the second bracket. So I've done that without any working out this time, but remember that you could, if you needed to, take this bracket and say 5x minus 2 equals 0, which means 5x equals 2, or x is equal to 2 over 5. If you still need to do that working out, that is fine. Okay, a few more questions down the bottom here. Question 5, solving the equation. Now these look a little bit different. We need to get them in the right form so that we can factorise them properly. So the first thing I'm going to do in this 5a here is I'm going to expand it out, which will give 4x squared minus 6. And then the minus 23, I'm going to move it across to the left-hand side, so plus 23x equals 0. Now that's almost okay, but we need them in the right order. We need the 4x squared first, then the 23x should be next, and the minus 6 should be on the end. Now that is in the correct general form so that I can factorise it. So this is non-monic. We're looking for numbers that times to give 4 times 6, which is negative 24, and are going to add to give the 23. So that would be 24 and minus 1. So we have 4x squared plus 24x minus 1x, or minus x, minus 6 equals 0. Factorising in pairs, we can take 4 and x out of the first two terms to get x plus 6. The third and fourth term, we can bring out a negative sign to get x plus 6, and that's equal to 0. The x plus 6 comes out the front as a common factor, and 4x minus 1 would go inside. Now, using null factor, we will get x is equal to negative 6 from the first bracket, or x is equal to a quarter from the second bracket. On to question B. If you have a fraction, you want to get rid of it. So the x that is on the bottom of this fraction, I'm going to multiply it over to the other side so that I have x plus 12 equals x squared. Now the x squared needs to be my first term. So that means I'm going to move these ones over to the right. And that would be negative x minus 12 equals 0. This is a monic trinomial, so this is a little bit easier to factorise. We can go straight to our brackets, and we can find numbers that times to give minus 12 and add to give minus 1. So that would be a negative 4 and a plus 3. So my solutions would be x equals 4 from the first bracket, or x equals minus 3 from the second bracket. Okay, question 6. More of these harder ones. Again, in question 6a, we don't want to have this x on the bottom of this fraction. So we're going to keep the minus 1 that's on the numerator, and the x needs to multiply over to the other side. But what the most common mistake here would be is just to multiply it to one thing. You have to put that x minus 2 in brackets and make sure you multiply that x into both of them. So now I'm going to expand that out. I'll get x squared minus 2x. Keeping it in the correct order for my quadratic, x squared minus 2x, moving the minus 1 over would become a plus 1 equals 0. This is now a monic trinomial, and adds things that add to give 1 and times to give minus 2 would be negative 1 and negative 1, or better still, x minus 1 in brackets all squared. Now, because both of those solutions were the same, this is a quadratic that will only have one solution. And so the solution to that would be that x is equal to a positive 1. Part B. We have fractions on both sides of this equal sign, so I'm going to do the cross multiplication method. The x is going to multiply to the top of the first fraction, so it's going to multiply with the x minus 2. And the 3 on the bottom is going to multiply with the 5, which is equal to 15. Now I need to expand that, x squared minus 2x, and the 15, move it across the left-hand side, so minus 15 is equal to 0. Now we can factorise it. So timesing to give negative 15 and adds to give negative 2 would be x minus 5 and x plus 3. Using null factor one last time, I get x equals 5, or from the second bracket, x equals minus 3. Okay, and we can now, or you can now do exercise 8F.